we talked about kind of with Docker, like you download software, right? And that downloading of the software, right? That's essentially like our images. Is Docker images? Yeah, Docker image ls. Sorry about that. So here, right, this is just like if you like download Google Chrome, right? And then you can run Chrome, all right? So that's our container. Like if we do like Docker run Ghost, okay? And that's your container. You can, sorry. So you see that this broke because this is by default, we're running the latest version of Ghost, and that actually requires, even though Docker's supposed to be good with environment setup, this actually requires another Docker image in addition to just this one. So anyway, we can use, as long as we do Docker run Ghost, let me make this bigger, :4.8.0. This version, this one is independent, so we can be good. So, all right, so this is like our, these are our images, and then we boot up a container, just like you start, Chrome or something like that. You can view the running container. You can view the running container by doing Docker container ls, and you see that? This container has a name. It's like Nervous Johnson. They just give you them randomly, and then you can see, it's running on this port in Docker. Okay, like it's not running on my host computer port. So we'll review this, but I wanted to just kind of show you this idea of a container. It's very closely related to like the running, which as we know is the running of an image, right? Just like when we turn on double click on Chrome, right? This is very closely related in like to the idea of a process on your computer. So every like application that you run on your computer is a process. Everything that's like currently running, and you can see them by typing ps-aux. So here you can see each one is given like a process ID, and then this is the command, right, that's run in order to boot it up. All right, so apparently this is Zoom, and for me to, when I double click on Zoom, it runs this command, and then Zoom starts. Okay. So you can, you can search for your processes generally by doing like ps-aux pipe, right? We get the output of this command, and we pipe it in as an argument to the next command, which we'll do like grep. And like say we want to search for Postgres. Sometimes you'll get, multiple matches, but you can start to see which one is probably it. It looks like this one, right? This is one that's running my Postgres app. And then if you want to kill it, you can do so with the process ID, okay? Which I think should be this. Hold on. I'm blanking. PS kill -9. Is that it? Would it be 832? Hold on. I must be doing the wrong thing. Kill process. It's just kill -9. Yeah, kill. So you can just do kill, and then you can type in the process ID, like 832 for this one. This should send a shutdown command to Postgres. We can check again and see if it's running. Maybe this was a different version. Let's see if this is still there. See that? It's gone. That's kind of interesting. Let's just make sure. ps-aux pipe grep Postgres. Yeah, so this one that you see, this is my searching for Postgres. You see it says grep Postgres. So that itself was a process that it's matching on. But all the other ones, it looks like are gone. I don't know why this is still here. I'm not quite sure. But generally, this is the way that you can like kill a process. You can also do the -9. I don't know if this will work because we already killed 832. But the -9, I believe, says like don't wait. Like when you quit like Chrome or something like that, it like performs a shutdown. So really, what this 832 does is like send a signal to like say in this case like Postgres to like start beginning to shut down. The -9 is like don't even wait for it to shut down itself. Just kill it. You can see that here, right? we already killed this process, so it's not there. But we could, potentially do that with something else. I can't find it. PSOX. Oh, pipe grep. Let's see if we can find Slack. Yeah, I can't find the actual. It's a little hard. I guess this is probably the ID for Slack, and this is the command it's running. Wow, what a thing. So if you wanted to kill it, right, you just do kill -9, and then we would put in this, right, and this would immediately kill that running process. So this is kind of one other thing to show with processes is you can also run. You probably should have in your computer the top command. This is a good thing, like to just know about, because. Right, you can see here it's organized by like CPU amount that's being taken up, and it's just like it stays kind of there and updates for you. So yeah, like running this and like seeing just what is taking up the different resources on your computer, and then you can you have the process ID, you can kill it if you need to. Right, this is a useful tool, and I did it literally just by typing the word pop into here. And then I press quit, right? So you can see 330 processes are running, right? And it gives you kind of the percentage of my usage, etc. So like, again, the reason why I go into this, we have a ratings on it that we'll deploy, is again, like going to that idea of a container, right? We have all this software on our computer. Those are the images. When we boot it up, and start running it by doing something like Docker run, right? The same way we can see the list of processes running on our computer, we can see the list of containers running by typing Docker container ls. All right? And now just like this was given a process ID, you can see this is given a container ID, and this is, it's also given this alias of a name. And because like containers are so similar to processes, you can also just type Docker PS, and that will also list all of the containers, because it is going off of that idea that a container is similar to a process. All right, so just to review a little bit, what we went through in the last class. Just remember, like, you can think of Docker, right, as replacing our virtual environment, right? And like when you run a container, you can think, okay, it has this box that's kind of booted up for you and is independent, right? Like it is isolated, I should say. So that way, it's when you see that a port is run, it's using port 2368. It means 2368 inside the container. I got a picture of like inside the virtual environment. Okay. So just remember, like, the purpose of Docker is to achieve the same, outcome, essentially, as a virtual environment, but to be more efficient, right? And the way that we do that is it saves, like, shared files, right? Or it shares common files or common, like, images across really different images, technically. It does that with the union file system. So, right, like, if two different images both need to use Python, it won't download Python twice, all right? It can use the same version of Python and make it look like that's in each of the corresponding images, right? We gave that example of if we have like a website and a chat application, and they both use Python under the hood, we can just download Python once, and for the chat application, it looks like Python is in its folder. For the web application, it looks like Python is in its folder, right? We also said that if one of them kind of alters, like Python or any other library, it doesn't really alter it. Instead, what it does is it performs a copy on write, meaning that it first copies the related file that you want to change, and then you edit the copy. All right? So this way, we can share files across different images, knowing that nothing is going to be like corrupted or altered, by a separate image inside of Docker. And then the last thing we talked about was just that, that when you boot up a container, you can see, okay, here's like the different images, right? Some of these might be shared, like this is like the layers that make up an image. And then some of these might be shared across, with other images. And then when you boot up a container, this part is writable. It's just the top layer, really, is what a container is. And that's where you can like write to stuff. And then we talked about namespaces. So namespace is the fact that each of the containers that you run all the processes are like self-contained in their own folder or in their own environment. So this is why when we do, where do we boot up? Sorry. Oh, here. When it says it's available on 2368, it's available on 2368 inside here, right? But if you want to actually access Ghost, right, and you run it and you're like, okay, I'm going to access it on 2368, it's not going to be available there, right? You have to expose the port in 2368, connect it to one of your ports on the host machine, right? So what we have to do is something like docker run -p and specify a port on my host machine. 2369 goes to 2368 in the Docker container. All right. And now if I go to which port, right? So the port on my home computer is 2369, and that's pointing to the port in the container of 2368. All right, and we achieve that with docker run -p 2369. Other things to show. Okay. So when you remember, like with processes that we showed, PSAUX. Let's just do them, right? Let's do Zoom. This is good. So remember with processes, like it tells you the command that's used to like start the process, right? That's used to like kick this thing off. When you boot up a container, something similar happens, right? What happens is if we go to, let's say we go to Docker Hub Ghost, and then we can click on this version, all right? So we click, these are all files. Like these are all considered part of the image. Every line here, this is everything that occurs for you under the hood. It starts with this other image, node, all right? So this is why it says like images consist of other images. So Ghost, that website, just builds upon this node image, and then it adds an environmental variable, and it downloads some stuff from GitHub, right? And we'll unpack this. We'll get to images later. But what I really want to show you is all this stuff is part of the image except for this one thing. When you do docker run ghost, whatever it was, 4.8.0, this is what gets run, okay? Just this. And now this line, current index.js, I'm supposing, is what starts all the rest, creating the tables, etc. The same way we saw when we, run Zoom, right? That one line gets run, and it kicks off, I'm sure, a bunch of different things that need to occur for Zoom to set up. But this is all that gets run, is this line right here, okay? So what's nice, the reason why we go into this is, let's say that you want to just, you don't want to boot up this one line and have all the tables get created, but instead, let's say you just want to dig around a little bit. Well, you can override this command like this. Say I just want to list the contents of the image. I can do docker run ghost 4.8, and then we'll do ls. You see, this is what, so we overrode this command of, hey, run this file with node, with inside the image, just list the contents of the image. All right. One thing that you often want to do is kind of connect into the image, right? So You can do that with Docker run. Yeah, actually, I think can we do it like this? So if we do this, like sh is to run the shell command, all right? And bash is also to run the shell command. Is to run bash. So if you just do this, you see that it did run the bash command. Just like the same way that we did ls, it displayed the contents. The problem is when we run bash, it completes, right? Like it achieves its purpose of running bash and it exits. Just like the same way that when we ran ls, it achieves its purpose of displaying the contents and exits, all right? It's for that reason that if you do this ls thing, really what happens is it boots up a new container for you, but then immediately it kills that container. So if you look over here, there is no container running. Unlike when we saw, like when we ran Ghost, and that this time it's saying, hey, boot this up and then keep listening, right? Keep listening. And because of that, here we can see that container running. It hasn't yet achieved its task, right? It's been given a command to keep listening, and that's what it's doing. So the point is like when you do something like this Docker run Ghost 4.8.0, and then we say, hey, I want you to run this. It will boot up a new container, run bash, but it will exit immediately because it accomplished its goal and it's done. So we need to tell it to keep persisting this process, keep persisting this container, and we can do that with this -it, I believe. And now we are inside. So now what we've just done is we've like booted up a container and we're saying keep connected, stay connected on the inputs and the outputs. So now you can see we're inside Ghost, all right? And now we can like dig around, right? And use, whatever we want really to like explore and see what's going on here. So just to recap kind of like this new component, we saw that, now we can do exit. We saw that really when you run a container, it's running this command, okay, at the very end of the file. And that with something like here, this node thing, it's saying like run this file and then keep listening. And because of that, we can view the running process, right? Like just like the same way when if like we run Python file and it finishes, that process is no longer running. In the same way, when we're told, for a piece of software to keep running and keep listening, it's going to stay there. And we can view that process by doing docker ps or docker container ls. And here you can see the running container. If, however, we wish to override that process, we can do that by at the end saying what we want to, the bash command or whatever that we want to override with. So here we're saying, hey, instead of run node, just display the contents. Because it successfully did that, we don't see a container for that, because you can imagine that like the image got booted up, it ran ls, and then once this was achieved, the container is automatically killed. When it achieves this goal, it dies. So if we want to do something like bash, where the point is to kind of like dig around and explore, we run into the same issue, which is it boots up and it dies once it achieves its purpose. So you have to tell it, hey, don't like self-destruct. Stay connected. And to do that, we have this -it. All right? So once I'm inside here now, you can dig around. You can, move into current, right? You can really explore. And lots of times I will do this, right? Like with a new image or something. Eventually we'll see like how to modify them. So this is a useful thing to do. And once again, the command is docker run -it, right? And then the name of the image, and then finally like the command. So in this case, it's bash. I want to show one more thing, but questions before I do that.
What's the difference between entry point and CMD?
Yeah, entry command always is the last thing that's run. And because of that, one benefit of it is like you can override this last thing that's run, right? We saw how to do that. Entry point is run, but it's not the last thing. Because it's not the last thing, it automatically occurs, right? You cannot override it. Okay, so lots of times you'll save command for the thing that you want. It should be the kind of ending kickoff point, but like also in a way optional. If that makes it's pretty obvious. Like Flask run, if we were building a Flask application, right? The Flask run command would be the last thing, and we could, instead of booting up Flask, do something else. Okay. So one other thing to show is just, all right, we can run Ghost. This thing's booted up. We can then go to a new tab. We want to see, we have the Docker images. We see that this is what we booted up, and then we want to actually show the running container. We do Docker container ls. If you want to connect to an existing container or like run a command against this specific container, not a new one, but this specific container, right? You cannot do Docker run, because Docker run, let's just do Docker run, I'll show you. This is going to boot up a new container if we do Docker run again, right? Like if I do Docker run and I'm like, hey, I want to dig into that existing thing, what this is going to do is actually give us two containers, right? So what we want to do is connect to this one, right? So you can do that with Docker exec. So we can have this guy running, and then at the same time we can sh into it with the Docker exec -it, the name of the container or the ID, followed by the command we want to run again. In this case, it's bash, right? So now what am I connected to? I'm connected to this specific container, right? That's useful because like this is an interactive website, right? Like things may change inside of it. So you may want to see exactly what's going on there. All right, so it's Docker exec -it, and then, well, this is to keep it interactive, and then the name of the container and the command you want to run. Right, like if you want to just like run the ls command against it, we probably don't need to make that interactive. I wouldn't know what that even means. But this, again, we're running this command against this specific container. So that's the exec command. The exec command only exists on a container, right? Do you all get at least the differences between images and container, right? Images, you download the software. Containers, you boot it up just the same way we kind of have like our terminal running, like, right? We could imagine having a second terminal running. We could have, same way we can have two containers of the same image, right? And then we saw we can override this like kickoff command, right? By just putting something else at the end of it. When we do Docker run, we say, hey, I don't want you to boot up, do that last command that boots everything up. Instead, just run ls, and then you're done. And then we saw how we can run a command. So this overrides the default command. We can also run a command against an existing container. Let's see, do we have any? By doing the Docker exec, right? And then Docker exec, let's say -it to keep the connection open, bash. Okay, and now we're in that running container. Okay. All right, so